guys. I'm Rosemary Wong. I'm a developer advocate here at HashiCorp. And today I'm going to show you a little bit of Vault. We're going to start with Vault, and then we'll go to Console, and then we'll go to Boundary. So we'll follow the flow that Chris outlined earlier. So we're starting with Vault. I will say, if you have any Vault questions, feel free to ask. We have Andy, who's a fantastic resource on here, and many other Vault representatives. If I can't answer the question, I'll happily defer to one of them. Who will be able to answer it. But what I wanted to show was following the zero trust security model, how a developer might perceive it. So you may not see as much of the operational security aspects, but at least you'll get a perspective on, from a developer standpoint, how this might fit in. All right, so this looks a little confusing. This is basically the architecture we're going to deploy today. And this seems to be a lot, right? There are a lot of components. Everything seems to be connecting to each other. I'm pretty sure you may have seen some architectural diagrams that probably are more complicated than this. But today we're going to focus on putting this system together. I have an application, and all it does is show some coffee that I can order. I'm sorry, the payment system doesn't work. It is shut off. So you will not be able to actually buy a coffee. But in this case, we're actually going to show at least the front end with the coffees moving. Now, for a very simple application, it's actually pretty complicated because you're trying to secure it, or you're trying to secure the connections between some of these machines as well as identities in this environment. So today we're going to use some HashiCorp Cloud Platform components. So this is actually what you would say the managed Vault and Console offering that Chris was talking about earlier. When we talk about managed Console and Vault, these are the servers. So the server plane is being managed by HashiCorp, and what we're going to deploy are actually agents that refer back to this control plane. The other thing we'll also be talking a little bit about is how to extend security beyond a mesh, right? So you might have a mesh that you can implement in a greenfield environment, but how do you extend the security outside, right, to a multi-platform environment? And then finally, I'll talk about the boundary workers here, which will control the human to machine identity access. So this will allow an operations team or a development team to be able to log into some of these machines. So that's a quick overview of where we're going to work toward today. So we're going to start with Vault. If there's any questions, feel free to chime in. I'll pause, and that way, if you have any specifics about Vault or something that you're seeing here, let me know. All right, so this is the application. Today, we're going to order a Vault latte. I did not make up these names, but the application is about N tiers deep. So you have a front end, a public API, a product API, and the products database. Today, we're going to take a very small piece of this and demonstrate how you would use this with Vault. The important piece will be that the product API needs database credentials. I think this is a very common use case where an application needs to access a database, right? And most of the time, as an application developer, you might embed these somehow, or you encrypt it. You figure out some way of getting those secrets to your application for consumption. But with Vault, you can actually do this in a very dynamic way. So you can issue new database credentials for each new product API instance that comes up. And we're actually going to show that today. In this demonstration, I'm going to show two steps. It is a two-step process, all of which is automated. So all of this works a little bit like magic. But the first thing we're going to show is how it's the machine instance, so that would be the products API, authenticates to Vault. And this is actually done through Kubernetes. So there's a Kubernetes service account, for those who are more or less familiar with it. There's a Kubernetes service account that issues a JOT, a JSON Web Token. And what it will do is actually use that to authenticate to Vault. So we've set up Kubernetes in a way that any of the JSON Web Tokens we want will authenticate to Vault appropriately. And there's a second step to this, which is to generate a new secret. So Vault will handle the generation of these new database secrets and the issuance of these usernames and passwords based on the instance of the product API. All right, so to at least show this from a more high-level view, before I dive into the CLI, because CLI demos, I get it, sometimes it's hard to follow. Basically, the first process is authenticate to Vault. So this is actually done through a Vault agent in the Kubernetes cluster. Kubernetes cluster has a Vault client that will reach back to the server. All of this is done, through the typical Vault authentication mechanisms. So what you're going to have is a sort of a preset policy to create the username and the password. And the username and password will then get returned back to the Vault agent, which will then write it to a file with the database username and password. Now, in the Kubernetes space, for those who are familiar with Kubernetes secrets, they're base 64 encoded. They're not actually secret. And so this is a great way to inject your secrets in a secure way on the actual pod level for Kubernetes specifically.
You have AWS here down at the bottom. Who's actually hosting that stuff? Is that my AWS environment, yours, a mixture?
Great question. So the HashiCorp Cloud Platform piece is hosted by HashiCorp. So this piece here is hosted by HashiCorp. You get a virtual network and you can peer to that network, which is this peering connection here. The Kubernetes cluster, which is wherever your applications are running, all of this is my network, or bring your own network. So you bring your own network, peer it to the Vault server in HashiCorp's managed network.
So then the part that you're hosting, how much control does the customer have or even need?
So it's actually, it abstracts a lot of the sort of the operational control, right? There's none of so HashiCorp is not going to be reading the data, right? But it basically, you can configure any of the auth methods and secrets engines that you'll need eventually, right? Right now, it's not at the place where everyone works, but you can configure any authentication method and any secrets engines that you'll need to access Vault. So if you have currently an on-premise Vault solution or your own Vault solution open source, a lot of the auth methods and database secrets engines, or sorry, not database, but secrets engines in general will be able to be applied as part of this. So from a control level, you do have the ability to access the same auth methods and secrets engines, but let's say you won't be able to access root namespaces or like a system level configuration. So we do prevent system level or root level configuration. So let me actually exit out of this, and we're going to flip to what this looks like in practice. All right. This is the HashiCorp Cloud Platform interface. This may be updated. I'm just letting everybody know. But right now, I already pre-provisioned a Vault cluster. The pre-provisioned Vault cluster is using public configuration. You can set it to private, but for the sake of this demonstration, I'm going to set it to public so we can dive into some of the Vault internals. The other interesting thing about the current, at least the current iteration, is that there's actually some audit logging available. So if you do want to access the audit logs from Vault, there's an ability to download them as well. In open source Vault, you can actually funnel this to any metric system or any SIEM that you decide you want to send it to. But in this case, right now, it's a downloaded access for audit logs. And most of the configuration is default.
Just quick, because you said send, is there an API where we can grab the access audit logs, or is this a classic syslog mechanism?
So I believe there is a sync that is a classic syslog system. I'll defer to the experts to confirm whether or not there is actually an API endpoint.
There is not, but there is a number of different ways for you to interact with the audit log depending on how you configure it. HTTP Vault has specific forms of the devices that you can use, but within Vault generally, there are a few different ways to interact with it. There isn't a specific API endpoint for interacting with it though.
Yeah, I guess most users are interested if somebody tried to do something with their Vault instance, yeah, and to have an early warning system, yeah, okay.
Perfect. Yeah. Let's see if we can get a link, but there is something we've been working on to better export and better demonstrate sort of what's going on within Vault itself. I'll show some of the audit logs today and what information they're actually printing out. Right, so the first thing is I am going to actually go into Vault. I've pre-configured Vault with a couple things. The first thing that I've done with the Vault instance itself is configure a database secrets engine. The database secrets engine has one connection, and that is to a PostgreSQL database. This PostgreSQL database contains my product information. So the product information is a list of coffees. There's nothing too fancy about it. You can do a lot of different things with other secrets engines to encrypt this data, but for today, it's just accessing the data. There's no additional wrapping or workflows that I put around it. I've also automated the connection to this database, right? So we'll be able to see the endpoint here. This is an internal only database. It's not externally available. And so I can only access it within my network, as well as there's additional security groups surrounding that as well. And right now it's using a Postgres username and a password. This is an administrative password. Vault can handle the rotation of these administrative passwords as well. This is not something I'm showing today. I'm just showing the identity, the specific identity that's going to be reading it. The other important thing that is in Vault is actually setting access control policies to prevent any additional access that someone, any additional access to the Vault API. So if I am an application developer, I don't need write access to the database credentials. I don't need to be able to change them. What I do need is at least the ability to read them. So I'm actually going to read database creds product. So this is the API endpoint for me to retrieve the database credentials. So what I'm going to do is, hopefully this works. If not, we're going to switch demo, but database creds product. So what I'm going to do is, as someone who is able to access Vault, I am a human user. I have a little bit of elevated access. So this is not a representation, but it's to show what happens when someone accesses that API endpoint. There's a username and password. So there's a database username, there's a database password. And you also get a lease duration. So this is something that, as part of, let's say, the question around IoT devices, you can choose how long those IoT devices have these credentials, or how long these credentials are valid before they expire. You can renew them. Some people, I don't recommend doing 5-minute database credentials. Most people are, they do want their database credentials a little bit longer, but for this case, we're actually doing a lease duration of about 1 hour. All right. So we're actually going to go through I'm going to deploy the product database first, the product API first, and then I'll actually show that how at least Kubernetes is authenticating to it. So Kubernetes authentication in Vault works primarily with a service account. As I mentioned before, there is a JOT that is actually being used to authenticate a specific service account, in this case, product. My product API uses the product service account, and it is going to authenticate back to Vault. So this has actually been preset from an access standpoint. You won't be able to, unfortunately, you won't be able to see the configuration here, but I've configured my Kubernetes authentication to allow for this to happen, right? So there is some elevated access within Kubernetes that you'll need to do this. Again, if you're familiar with it, it means that you do have some admin requirements that you'll need in order to set up this Vault injection on Kubernetes. And as most authentication methods, you will need some kind of elevated access to set it up. So I'm going to actually check out the products pod right now. The products pod here has, it has a couple of containers running. So there are many different containers that are part of the product here. But what I'm actually going to do is dive into it and actually show you what is being issued. So remember, we did that database creds read, right? So we read the database credentials, we got a username and password. What I'm going to do is actually go into product and show that there is actually there's actually the same username password, different username and password in there. So let's actually do this. So there's a configuration that's going to be written out. Notice that there is now a username, right? This is similar to the username we had before, as well as the password. So for 1 hour, this pod will have the ability to access this machine, so to speak, this identity will have the ability to access Vault and read from the database, right? So I can actually check out how many of these have been issued. So far, I've had one pod here. So this is one lease, and then this is probably the other ones that I was doing when I was reading from the database. So Vault itself is checking into this, making sure that it's good. Important thing is, let me actually reissue it, and someone has to remember this because I probably won't remember it entirely. Oh, look, it failed. It did fail for a reason, but this thing here, because it is actually going to restart, it will actually reissue a new set of credentials. So right now it's crashing and it'll come back up, I promise. But as it's doing that, it will actually reissue a new set of credentials over time. And these will all be different usernames and different passwords, depending on the pod identity specifically. So you can always recreate something and reissue a new password.
This might be a simple question to answer, but does it explain why it failed?
Yes, it does actually explain why it failed. And it was not from Vault. It is because there is something that is not configured. There's actually some network policy that's blocking it from communicating to the database. And I'll actually show that in the console section. But I can actually show you why it's running now. But we can actually show, I'll be able to show that.
While you're doing that, I just want to confirm you are saying that it is indeed the network this time.
It is actually the network this time. You notice it says error, unable to connect to the database. This is intentional. It is actually not connecting to the network because I am denying the policy to allow it to do so. So in this case, I actually am crashing it on purpose. And the logs basically are saying it's unable to connect to the database. But it doesn't say exactly why, and the why is actually because console's preventing it from doing so. So in this case, when Vault is actually doing this, and as you have more identities and more secrets engines, there's, you can actually choose the kind of access that an application will need. So if someone does need, or if some application does need some kind of access to write something, you can set a policy to do that. And that would be done through the ACLs. So in this case, if I actually look at the ACLs, I don't have too many available right now, but if I had other services, I could add an access control policy to prevent it from accessing the database credentials, for example. The other important thing, which I did mention before, is actually accessing the audit logs. So I did have audit logs running. I guess let me download them. And so this will actually show me whether or not my pods have identified themselves to Vault, who authenticated, who didn't authenticate. So it's going to take a bit of time to download.
How familiar does one need to be with Kubernetes to use the products?
So you do not actually have to use Kubernetes at all. Most of the actual Vault workflows can be used with virtual machines as well. You don't have to have any familiarity with Kubernetes. Kubernetes has been a very popular workload integration that we've had in the past, but a number of things, if you're doing this on Azure, for example, you can use, let's say, the JOT machine identity that is generated by Azure to also, let's say, authenticate to Vault as well. You can issue, service principals for Azure. You can issue AWS secret access keys. You don't have to have any familiarity with Kubernetes specifically to use Vault. If you do use a Vault integration for Kubernetes, you do have to have some knowledge of how the Kubernetes constructs work just to set it up initially. But we deploy by Helm chart. So out of the box, you get a lot of the configuration you need without necessarily going too deeply into the Kubernetes internals.
Okay.
What other integrations do you have besides Kubernetes and AWS?
So for Kubernetes and AWS, we have a lot of them. So let's see. So for auth methods, I'll show a link later. There's plenty of auth methods here. Some of the more popular ones that I've heard, and some folks can definitely confirm if I'm wrong. There's LDAP, Okta. You could do TLS certs if you want for authenticating to Vault, right? So there are many ways you can authenticate to Vault, and these are some of them. GitHub is included in there. JOT, OIDC, which covers a number of use cases. And then for the secrets engines, so the secrets engines are the ones that generate specifically the tokens and any of the secrets. There are a lot of them. And most of these will be able to actually rotate and revoke any of the secrets that it's generating. So for example, you can create AWS access keys and then revoke them with Vault as well. You can also have key values. So this is just static secrets if you want to store them. You can also do that as part of key value.
So I guess this list is also constantly growing, yeah?
Yes, it is constantly growing. And it doesn't account for any of the community ones as well. Use at your own risk. We don't necessarily, so the ones that are on these lists, we've at least vetted and absorbed as part of Vault itself. There are community ones, like folks have written integrations to other secrets engines for you to be able to rotate and revoke based on any platform of your choice. So some folks have written Fastly ones, but they're not on this list mostly because they are community related, right? And they're, we don't guarantee necessarily that they've been vetted or they have been fully integrated with the Vault ecosystem.
That means if we have engineers and too much time, we can start developing our own. Yeah.
Exactly. I have done it myself. I was very fortunate. It did get absorbed into Vault 1.7, so I'm very happy about that. But it did take time, and it is Golang based. So if you do have engineers, who want to develop, they have to know Golang to do so. Let's say I have the audit logs. I'm going to download them from a certain, timestamp. In this case, I downloaded them a couple days ago at 2 p.m. And once they download, you can extract them using, let's say, download. You can extract them using gunzip, which is one of the utilities on Linux. I'll skip through that piece. So extraction. And when you actually print out the audit logs, there's a lot of information in there. Notice it's kind of like a syslog kind of look to it. Although it is JSON, there are JSON messages as well. All right, so I actually, in this case, wanted to check for Kubernetes related pod identity, right? So did my product authenticate to Vault, right? Did the Kubernetes product application authenticate to Vault at the specific particular path, et cetera? So as you can tell, it did. There is actually an admin auth Kubernetes default product. It's telling me it is coming from Kubernetes. There's actually some policies, so I can actually tell that there is a default policy that is also associated with product. And there's some service account names. So for example, I mentioned before, I attached a service account that issued a JOT, and that's the service account there. And there are many other kind of nice pieces of information in here too. So it tells me which secret I accessed as well as the lease. So yesterday I had a lease ID of KIL here, and it told me that this is the one that's associated with the database username and credentials that I've issued. Notice it does not actually print the database username or password in here. It prints the lease ID. So if you do want to correlate the use of a username and password, you have to correlate back to the lease ID.
Just a small one. Is there already a parser for that available for Splunk? Do you know that maybe?
So there is actually an exporter for Splunk, but it is not available on the cloud platform. So if you have an open source deployment of Vault, you will be able to forward that to Splunk. And please, any of the Vault folks, please correct me if I'm wrong there, or if you have more details about the Splunk exporter.
Yeah, no, that's totally correct. Yeah, there's a Splunk app that you can wire up. So it's just like an app you download, and then it'll give you all the dashboards if you're using Splunk Cloud or something like that. And then you wire up the, you can get logs as well as telemetry. So if you want to see gauges of, hey, how many secrets am I adding over a certain period of time? There's a huge amount of telemetry data that you can pull out of Vault as well. So yeah, both those streams of data can be piped over to Splunk. But there's
the monitoring use case is also covered, yeah?
Yeah, absolutely. There's a whole slew of folks that are also using, say, like Grafana or Elk Stack or something like that. It's not just limited to Splunk.
Sure. Last but not least, because you mentioned monitoring, have you seen, I don't know if you have something that is requesting a lot of keys, some performance things that you should be monitoring? Could it be, I don't know, if you have something that is requesting a lot of database keys or something that you get into problems regarding performance?
We have a guide that talks around monitoring best practices, and through there we give you sort of the highlights of, hey, you should be checking out these particular things. And we've curated sort of a list of those things into that Splunk dashboard. So you can go download that app, and it gives you sort of like a pre-canned best practices way of looking at it. But if you wanted to use something like that on Elk, you'd have to go and basically do it yourself, but you could just copy it from the Splunk app.
Okay, so my question was more regarding from your experience, from a performance standpoint. Have you seen customer penetrating your system and bringing it to a level where you had problems with delivering the keys, or that is pretty much high performant and should not happen?
Maybe Andy, you can chime in here too, but I think we have such a wide range of customers that customers are always exploring boundaries of the product, right?
Yeah.
Especially when you talk about those different secret engines. If hey, I'm using static secrets and I'm doing 10,000 requests a second or something like that, and then hey, I want to migrate that workflow over to say open LDAP. There's a lot of dependencies that we're connecting to remote servers that might not be able to handle that. So it's tough to give just a generic answer because like each one is going to have pros and cons.
So from my customer side of things, always we have to benchmark and find out where are the limits of the system to have in the monitoring also the right thresholds where we're getting alarm and saying, okay, now we are at the end of the performance stack.
Yeah, absolutely. And there's the exact same methodology applies to Vault.
And something as a sort of a preventative measure, because I think this has happened before. There is a rate limiting capability, so you can limit based on the requests and leases. So there is a preventative measure now to do it, but it does, as you pointed out, people will do what they will do. And so far, I think it's been pretty unique. The folks that I've talked to, at least in the community, who've run this open source and are responsible for doing this themselves, they find ways around it. And they're very excited. They were very excited about rate limiting specifically because then they could actually make it more preventative in nature.
Developers and too much energy drink, crazy things can happen. Yeah.
Yeah. And if you imagine in Kubernetes, you just notice this crash and restart repeatedly. How many times does a pod crash in Kubernetes or any container orchestrator crash and reload? It's very easy to do that and can constantly be reissuing new passwords, credentials to the system. So it is a use case that does happen. All right. So just to wrap up this section, at least in terms of the 2 steps. As I mentioned before, it usually involves authenticating Default. So there is some kind of integration or identity that you'll need to put together. And this is, I mentioned the huge list of auth methods and secrets engines, but some of the most prominent ones, IDC, JOT, LDAP, Okta, GitHub, etc. And on the other step, which is generating the new secrets. So this is issuance of new secrets based on identity or based on certain credentials that someone will need or any machine will need. You have transit, which will encrypt information, GCP, AWS, Azure, PKI, which is for certificates, and there are many, many more. So if there's anything in particular that you're interested in, always feel free to ask. Otherwise, I'll give maybe 2 or 3 minutes, and then we'll move on to console, and we'll fix that crashing problem that is indeed the network problem.